Thanks for joining the Dell SDN session today. My name is Shabbir Ahmad, and I look after Dell networking business in EMEA emerging countries. So today's topic is open networking, which is Dell's SDN strategy. Feel free to ask questions if there's any question in between. And before I start the SDN presentation, I would like to give you some view on, the new Dell Technologies company. So probably you heard of the announcement we had on 7th of September of the joint company called Dell Technologies. It's no more Dell. Well, we have under Dell Technologies, we've got Dell Technologies, and the rest of the organizations like VMware and other ones. So basically, with this joint venture, we are the largest privately controlled company, with the EMC and the whole Dell portfolio and rest of the portfolio. So you can see the hardcore of data center solutions, server, storage, networking, is the core of our infrastructure solutions group, basically. And then around it, you can see from workload-driven solutions all the way from file and sharing, all the way to hyperscale solutions, VDI solutions, public and private cloud solutions, fitting into all kind of workloads at the bottom here. So the vision of, of building such a large portfolio with the joint, companies from both sides is delivering a future-ready enterprise to the market. So what future-ready enterprise is basically a highly scalable end-to-end approach and rapid time to value, superior ease of use kind of technologies, moving away from traditional proprietary solutions, community solutions, and legacy systems. So that's the vision, and that's what we are aiming to deliver in the market. So that's about overall vision. Coming back to the networking. So just to give you a glimpse on where we stand with the SDN, where we stand as a Dell networking in the market, right? So you can see in the Gartner networking, back in 2013, we were one of the niche players, one of the visionaries in the visionary quadrant here. And then gradually we have moved up. And if you look at the latest quadrant here, we are and it's only Dell and VMware as a visionary. And what makes us visionary, basically, there is, again, our open networking strategy and the SDN strategy going forward, and that's what we will talk about in this 30 to 40 minutes presentation. So open networking is Dell's SDN strategy, right? What open networking is, if we just go back a little bit, we can see in the traditional networking, what we got in the traditional networking. We got proprietary ASICs in a typical chassis, right? We got proprietary operating system in each chassis or in a switch, basically. And then we got proprietary protocols and the whole stack there, which is moving. The whole industry is moving, and we were a bit ahead in the market with our vision a couple of years back. In the open networking space, where we started building switches based on the merchant silicon. So the proprietary ASICs are replaced by merchant silicon, and proprietary operating systems, network operating systems, are replaced by a list of choices. So this analogy, just to make it understandable easily, you can compare this with what happened in the server industry. Some time back, we had mainframes, Sun Microsystems, and different other Unix platforms, which have all transformed to what we call it an x86-based industry standard machine. All the customers, they go out and buy an industry standard machine today and comfortably put it in the data center in a kind of a virtualized environment, and we are confident that our application is going to work on it. So it's pretty much standardized on the hardware side. You decoupled the software and hardware there in the server. And this is exactly what's happening in the networking here. So open platforms and open operating systems with a choice of platforms, basically. When you buy an x86 machine in the market today, you get a choice, right? You get a choice of hypervisor. You get a choice of applications on top of it, operating systems on top of a hypervisor, right? You're no more locked down to a specific application a specific operating system on a specific processor or a hardware platform. So you decouple that there, and it's exactly what's happening here also in the open networking. So basically, we're talking about a bare metal hardware when it comes to networking, and then an operating system layer on top of it, and then we're actually going a step ahead of just decoupling the operating system from the hardware. We'll talk about our open OS 10 platform, operating system 10, which is basically a very advanced platform when it comes to open networking. So if you look here, we got Broadcom chipset, right? Instead of proprietary ASICs from a specific vendor, we got the switching platform on top of it, and then the open networking choices, the operating system choices there. And then the SDN controllers and the OpenStack plugins on top of that. So this is what we do. We do, from the operating system solutions, we decouple switching software and the switching hardware, right? So we combine them together. We don't ship anymore a single bundle of a switch with a CLI, and we let you buy a switch against feature set mentions in a datasheet, right? So you cannot go away from the features mentioned in a datasheet, the software features I'm talking about, right? So we decouple that, and we give you choices here. And when it comes to overlay solutions, we also decouple that in the overlay solutions, right? So we have got physical networking and then the virtual networks there on top of it. And also we got control plan and forwarding plan solution when it comes to pure SDN solution, both for campus and data center, basically. So here are some of the the use cases we have based on open networking. So we can, starting from an industry standard OS CLI, call it, the famous CLI in the market, which is pretty much common across all the vendors, right? For data center and campus, and then we can go to layer 2, layer 3 campus networking. We can develop on the same hardware. We can develop WAN, MPLS, VPLS functionality with IP infusion, and you can see from carrier core to Metro Ethernet and all kind of solutions for service providers we can build based on an open networking concept, basically. We use a multi-terabit switch, 1U, 2U, 3U switches. We have got multi-terabit switches. We put a software called IP Infusion on top of it, and that gives us all of that functionality. And the same switch can run industry standard CLI, and the same switch can run your MPLS network in a very simple and a very cost-effective way. So improving simplicity in the data center and driving down the cost, that's the whole motive here of open networking. And then also on the enterprise WAN side of it, if you look at the list of, on the right side, the list of, I'm sorry, I've got a pillar in the middle, so I have to move back and forth, left and right side. So on the left side of it, you can see the choices in the campus, starting with the SMB on the SMB side, OS 3, OS 6. And then we got big switch fabrics. So big switch is very well known. Probably some of you or most of you are already aware of big switch networks, right? So they deliver purely SDN, commercial grade SDN solutions. And we certify it and we jointly deliver big switch based fabric solutions for very large data centers, small to large data centers. Basically, we adopt a concept, and I'll explain that in a very detail about how that concept works, comparing a classic network or a classic fabric for the data center using Big Switch. So in Big Switch, we got two solutions. One is the Big Switch fabric for the data center, and also we got the Big Switch monitoring fabric. So, so the monitoring fabric is purely for monitoring purposes, for tapping solution, the commercial, very highly scalable tapping solutions we can build based on the Big Switch tapping solutions. Also, we got Cumulus Networks. So Cumulus Networks is a native Linux platform running on the same switches, same data center switch platforms, giving us a lot of flexibility, and I'll show you the details about what we can do with the Cumulus Big Switch, IP Infusion, Plumbus also. So Plumbus is a controllerless SDN environment. All of these are basically giving you a range of choices. So you can buy a platform, a bare metal switch platform for your data center, and you are not locked down to a switch feature set, right? So that's a very important point. You want a feature today, MPLS, and tomorrow you want a tapping solution or a controllerless SDN. All of that you can do just by changing the operating system in your environment, in a leaf and spine environment. So I'm not going to talk about the products. Our products are available. The details are available on the internet. Basically, we have got very high performance switches right from 1 gig, 10 gig, 25 gig, 40 gig, 50 gig to 100 gig. All kind of speeds are supported on our data center switches. Different kind of configurations, modular fixed configuration switches are there. But in simple, our data center range of products, top of switch range of products are called Z series and S series. So you can see Z series, S series, and then the M series. So we just give them abbreviations. So Z and S are the data center products for the core leaf and spine designs. And the S series is typically a top of rack switch. And then we got M series, which is modular, which fits in our blade server switches, blade chassis. Right. W series is our range of wireless solutions for campus. And also we got N series, which is our flagship access layer switches. So N series is highly scalable range of switches we have got with the PoE Plus and very advanced features with 1 gig and 10 gig uplinks. All kind of layer 2, layer 3 protocols are supported on N series switches, basically. So starting with building those fabrics. So we have different options, different ways of building those fabrics, depending on your business requirements in your data centers. To start with, if you want investment protection, you don't want to jump into a native, full-blown SDN solution, right? You want to start with this industry standard CLI. We have got tools to do that. We can use our standard OS 9 today, OS 10 going forward, and also management tools like Active Fabric solutions. Active Fabric Manager is a tool which we can use to design basically a leaf and spine fabric for your data center. And then we got two options. We can build a complete solution for the data center from core to the access layer, right? Or we can plug that into an existing infrastructure. If you have got your own existing core switches from any vendor in the market. And one very important point to note here is that all of those options we got in our portfolio, they're all based on standard protocols. We don't have a single proprietary protocol in the whole range of solutions. So it will perfectly plug into any of the existing cores if you want to do a gradual deployment or if you want to scale basically on the SDN side while keeping your legacy systems as is untouched in your data center. So both options are there, down to the top of rack switches and up to the core layer. Now, let me explain in detail for some of you who are not familiar with the leaf and spine designs and the fabric solutions. So this is our typical switch chassis, right? We all know this. What we got in a typical chassis, we got supervisor engines or root processor modules, and we got line cards, and we got the accessories around it, right? Power supplies or whatever, different vendors have got different modules, but there are supporting modules for your environment. So the key components are the chassis itself and line cards and the supervisor engine. So supervisor engine or root processor module is typically the brain of your switch. All the decision making, all software part lives there, and all the processing happens, the core processing happens in your supervisor engine, right? So what we did is, now this one is, if you remember my first slide, very first slide, where we said that this environment comes with a lockdown architecture, limited capacity, limited scalability, and a fixed set of features coming with that switch from the vendors. We had those switches some time back, right? We had probably, with the Force10 acquisition 3-4 years back, probably the largest core switches in the market. 10 years back, we had 5 terabit switches in our exascales. But that was, if you look at today's world, that was an overkill, a 21U switch having, consuming 8,000 plus watts of electricity, taking one full rack and a lot of cooling requirements was an overkill for data centers. We adopted this fabric design, the smart fabric single-tier architecture for data center years back, actually. So we transitioned to this model, and the model is basically moving the supervisor engine outside to those 1U, 2U switches, and basically classifying them as what we call it spine layer, right? So spine layer of your fabric in a class architecture is acting like your supervisor engine. And then we got backplane, right, which is the core of network. Sorry, so this can be the spine layer. We got, it depends now on a controller-based or a controller-less SDN, right? So this is a big switch controller-based architecture explaining the whole solution, but it can be controller-less also. So the top component you see here is basically, it can be built into the switches as well in some of our designs. And then we got the line cards, right? And then the service modules to deliver different kind of services we want to deliver in a class architecture. So this can be a software-defined based tapping solution from Big Switch or a fabric solution, data center fabric solution, okay? Now you can see that in this whole solution, we don't have those 3 tier, the classic 3 tiers. It's just 1 tier, spine and leaf, and you can scale this out on, horizontally, depending on performance and scalability requirements and connectivity also. It supports all available technologies today from 1 gig to 100 gig there at the access layer. So that design we can build based on Active Fabric Manager, our choice number 1, with the industry standard CLI, right? Where we got Active Fabric Manager, Dell's Active Fabric Manager, basically building that Z series, S series, or combination of Z and S series. Basically, we can build that design all the way, and the tool basically helps us design, build, and manage from a single pane of glass, basically the whole environment as a single core switch. So we don't have to deal with the multiple switches at the same time. And also, we use industry standard protocols here. What that means is you can plug into this class architecture any other switch which is basically following the same standards, right? So if anybody is supporting, any other switch is supporting the same standards, you can plug into it, right? So that gives us a huge amount of flexibility in building a fabric for the data centers. Now, the choices there are OS9, which is our mainstream CLI operating system, right? And it gives us all kind of advanced features of development, scripting, based on Python, Perl, OpenFlow, and all kind of scalability options are there. We also are launching, we already announced our operating system 10, which is the most advanced form of open networking. It goes a bit beyond just splitting the operating system and the hardware, right? It even gives us kind of containers for the configuration, configurations modules, basically. So you can split the OS and hardware, and then OS further to your configuration. So you can do that there as well. And there are a lot of features. There are it gives you native Linux running. It's not a custom Linux design for your box, but it's a native Linux. And then you got third-party applications for automation, and you got it's basically all kind of L2, L3, and policy control and management features in there. We'll have a detailed session today later on OS 10, probably around 5 o'clock, I'm not sure. One of my colleagues is going to present that. So that will be only session on OS 10, talking about advanced features of OS 10. Big switch fabric solutions, quite interesting. So I mentioned briefly about big switch fabric solutions. Again, the concept of big switch fabric solution is a controller-based SDN, commercial grade, right? So it's the whole environment is built on a commercial grade, pre-built, pre-tested, validated design. And we as Dell EMC, we bring in that solution together as a single solution, one big switch to you. So all you get is a one big switch controlled from a controller for your whole data center. So this can scale to very, very large data centers. We have got deployments, one of the recent deployment to Verizon in US, which was a complete integration from end to end, basically from hypervisors to the cloud integration on big switch platforms. So what big switch does is, in simple, from the architecture point of view, in big switch we got again those spine switches and then the leaf switches, and we built blocking, non-blocking design the way we want to do it. And once we design that, the controller takes control of the everything. You create templates. You can create number of customers, as many as you want, and you can push the templates, and it will build those networks, virtual routers, virtual gateways for each network on the fly, on the go, without going through any complex scripting and any complex designs. It makes the whole life easier, especially in a service provider environment, basically. So the controller, again, takes care of all kind of monitoring, maintenance, operational tasks. Everything is taken care. It's a high available cluster, basically, outside of the network, doing all the operational and administrative tasks for you. One very important to note here is that big switch can fit into a data center, not just in a virtualized environment, but in a physical. So the servers which are physical or virtualized, it doesn't matter. They can all be part of the same fabric at the same time. And it will manage down to the virtual switch level or down to the physical NIC card level on each server. Big switch monitoring fabric, tap fabric. So this is, again, a highly scalable monitoring solution. So you can compare this with the classic tapping solution in service providers coming from Gigamon, Ixia, VSS, and other vendors, right? On a very highly commercial grade compliance kind of monitoring solution we can build using our multi-terabit ZN S-series switches and big switch monitoring software, we call it BMF, running in our switches and it doesn't have to be in a class architecture, by the way. For smaller setups, it can be as low as a design of just 2 switches. So we basically have got 3 types of ports in a big monitoring fabric. So we got monitoring ports, which are fed in from outside. And then we got delivery ports, the ports delivering that monitor traffic to the tool sets, right? And then we got the service ports for serviceability and monopolizing the packets if you want to manipulate the packets on the network. The beautiful thing about this is that, again, it's highly scalable and highly simple and cost-effective. Central management, point of management, so you don't have to deal with those different chassis-based or non-chassis-based silos, basically, you have today for tapping solution. Everything will be managed, all tool set, all delivery ports or monitor ports will be managed from a single pane of glass, which is quite unique comparing traditional monitoring solutions. So this is purely SDN-based monitoring solution for telecom traffic, or for normal IT monitoring purpose, or lawful interception purposes. So all kind of purposes can be fulfilled with the big switch monitoring, tap monitoring solution here. And this can also be scaled from 1 gig, 10 gig, up to 100 gig, right? And another interesting thing is that, so this is, in classic monitoring terms, this is NPB, yeah? Network Packet Broker. That's what we call those Gigamon, Ixia, and VSS kind of solutions. Now, you do not have to buy a complete NPB solution on day one. So it can be a complete solution on day one, but the most interesting part is that you can plug this into an existing NPB from Ixia, Gigamon, or VSS, or any other vendor. So that will work as a packet broker, and our devices will work as a packet forwarder only, or aggregator. So it will bring in all the traffic and give it to the NPB to do the processing. So we can either do the processing if we have a complete controller and service node, right? So we have got service node also if you want to do, service chaining, and if you want to do time stamping and different deep packet inspection or different kind of functionality on the packet broker, we can do that with the same solution. Or we can just plug into an existing environment to forward it. Okay, one more very useful point I would like to mention here is that comparing traditional monitoring solutions, we can do inline monitoring as well. So traditional monitoring solutions, you have to have passive taps, right? So put the monitoring solution out of band, out of the man traffic, production traffic. So in some cases, there is a requirement to put the monitoring solution in line in the line of the traffic. So the traffic will come to our switches. So the switches will act as delivery monitoring and service ports. You don't have to have passive taps. There are several advantages of doing that, right? So one of the advantage is that the switch is aware of the top router sending traffic in. So it will detect any failures in the router and route it, to basically do the load balance or failover to another environment. In case of passive taps, it will not know if there is a failure up there, so you have to build parallel platforms to do the monitoring for the whole environment. So it's very highly simple, cost-effective, scalable, and a lot of benefits in terms of monitoring for different purposes. Cumulus Networks, some of you probably, I heard today, some of you are already using Cumulus Networks. I think this is one of the first platforms we supported on our open networking portfolio, right? So Cumulus Network is basically a native Linux environment. You can build behind the Linux platforms for highly scalable environment and highly flexible environment to extend your existing development work, existing scripting to the network layer basically, and unify all your Unix environment into a single environment rather than maintaining a boundary between your network and the system's platform. So it's a single unified platform, single development environment from a software point of view, basically. Plumbus Networks, another unique software-defined networking solution we've got. So Plumbus is a controller-less, highly intelligent in terms of analytics, data analytics on your data center fabric. So when we build that same class architecture with the spine and leaf, remember in the first solution we put a controller on the right side, which controls and builds the whole fabric. In case of Plumbus, you don't have to build a controller. Controller is built into the switches. It's distributed across all the switches. It automatically discovers the fabric and builds the fabric. When you connect to the fabric, you're connecting to one of the switches which nominates itself as a controller of the whole fabric. So based on that fabric, you manage the whole environment, right? And also, that fabric or the view or the management view will give you detailed analytics up to layer 7. So it has built-in profiles, built-in templates to give you basically insight on specific data like big data and other kind of applications, give you analytics about how many hits, how many connections and streams and utilization and so on. All kind of analytics is built into your network basically to layer 7, which is a great advantage for specific environments basically. So this is NSX. Probably most of you are aware of our host-based NSX solutions. So VMware NSX, I think we have a session separately, and we can discuss that in detail. But it's it's SDN solution and end-to-end, very unique proposition. I would say if anybody is looking for security, micro-segmentation in the virtualized environment, and control of the network, underlay, overlay solutions, built-in VXLAN, and other advanced features, east-west traffic management from the security point of view, the NSX is the right solution to go. IP Infusion, I briefly mentioned in the beginning. It's for MPLS and wide area network solutions. We can build on the same. And by the way, all of these solutions I mentioned earlier, all of them, they run on the same platforms. I'm just talking about different operating systems fitting on our open networking portfolio. And the advantage of each solution, it's all pure SDN environment. So you're not changing your hardware layer, keeping the same layer, and depending on the design, you scale it out in a class architecture, but you keep switching the OS. So I'm running out of time. I have to go a bit quick. So customer successes, we have many customers, very large customers. We have few here, in Poland also. We've got a couple of them across EMEA, but we've got many in US, and we can talk about references later on. So with that, thanks a lot. If there's any questions, please feel free to ask.
Moment.
Sure.
I have one question regarding segmentation. So whenever you're using any kind of open operating system on switching platform, you say you can build a fabric, so have one controller for the whole fabric. But can you, for example, divide your network for using the same solution on the different solutions to different operating system for like in divided way. So some part of your network will be running this platform for this usage, and second for some other, for example, some for the EVPN and other for like internal fabric and overlay network.
Yeah, this is doable. I mean, it all depends on the design. We can sit down, we can build a design. So what I understood from your question is that we have one physical infrastructure, but can we have multiple operating systems for different business needs? Yes, but we have to design the physical infrastructure to fulfill the design requirements. For example, we need 2 spine modules. For example, if we build a network of IP infusion for MPLS WAN, and we want to do an enterprise SDN for the data center in the same environment, right? Both of them require basically, we have to build a class architecture for both, right? So dedicate 2 switches as a spine for this network and 2 switches as spine for that network, because the decision making, the brain is basically right now split between the 2 different solutions. Right, and then you need high availability there. That's why you have to put 2 there, 2 here. And then the leaf switches, depending on the number of ports you want for connectivity. But from manageability point of view, yes, it can be one network on the back of it, and it can be one infrastructure. And then you can basically, depending on the utilization, you can allocate switches for this side or that side of your requirement. So that's the whole beauty of the solution, leaf and spine design.